And now, coming to you live from my basement, Pre-Calculus Math 11. Today, how to name triangles, when to use sine and inverse sine, right triangle trigonometry, refresher. When we name a triangle, we name it with uppercase letters, referring to the corners or vertices of the triangle. For instance, the right triangle ABC, as seen here. When we're naming the sides, we refer to them by lowercase letters, and we do that by using the same letter as the corner that it's opposite from. So, this side down here, this side is called little a, opposite from angle A. The hypotenuse is little c, opposite from angle C, and the side on the left here, little b, opposite from angle B. When we write the trig ratios of angles A or B, we can write them as sine of A is A over C, instead of using opposite, adjacent, and hypotenuse. Now if someone came along and said, "Hey guys, I measured side C, and it turns out that C is 7.6 centimeters. Oh, and I also used a protractor to measure angle A, and angle A is 31.6 degrees. Isn't that great?" Well, we'd probably say thank you, and then we'd also chastise them for not measuring the rest of the sides and angles while they were at it. However, after that, we'd carry on with some basic trig operations to find those values. So, to find side B, we would use a trig ratio that involves angle A and side C, the two things that we know. Well, which ratio involves angle A, side C, and side little b, the one we want to find? Easy. Cos of angle A. Putting in values we know, we have the cos of 31.6 equals b over 7.6, and 7.6 times cos 31.6 is equal to b, giving us b is 6.473124, or is approximately equal to 6.5. Now, of course, the easiest way to find the measure of angle B would simply be to subtract 90 and 31.6 from 180 degrees, getting a total of 58.4 degrees. But let's pretend that we've forgotten about that, and let's practice using trigonometry instead to find angle B. So to find angle B, I'm going to have to find a trig ratio that involves the given side length of C, which is equal to 7.6, and also the value of B that we calculated over here as 6.5 centimeters. What involves angle B and sides B and C? Oh, there it is. Sine of B is B over C. So substituting in values that we know, we've now got sine B is 6.5 over 7.6. To solve for angle B, we want to get our calculators to give us the angle. We know that this is the sine ratio. What's the angle? So we type second sine, which gives us this notation, sine -1. It looks like it's saying sine to the power of -1, but it actually means, here's the trig ratio of some angle, give me the angle. In some textbooks and on some calculators, it tries to avoid this confusion between inverse and to the power of -1 by using the term arcsine or asine to mean sine -1 or inverse sine. And similarly, they use arccos and arctan for the inverses of cosine and tangent as well. So carrying on, we type this into our calculator and we get angle B is 58.78881 and so on, or angle B is approximately 58.8 degrees. But wait a minute, why did we get 58.8? Because when we did the subtraction from 180, we said the answer is 58.4 degrees. I mean, those two numbers are close, but they're clearly not the same thing. This isn't right. Why isn't it right? It's because of rounding. We said that B was approximately 6.5, which it is, but it's not exactly 6.5. We used a rounded off value here in our calculation for the inverse sine. If you have a rounded off answer here and then a rounded off answer here, you introduce more and more levels of error into your final calculation. So we never want to use a rounded off number until we get to the very last step. So here's something we could have done that would have been slightly better. I'm going to get rid of all of this first. Instead of using 6.5, I'm going to take the calculation that we used to get 6.5. Sine of b is 7.6 times the cosine of 31.6 degrees over 7.6. And the neat thing there is that the 7.6's cancel off, and so I've really got sine b is equal to the cosine of 31.6. Angle b, therefore, is the inverse sine of whatever the cosine of 31.6 is. Angle b is 58.4 degrees. So there you go. That's been a refresher on how to do basic things on your calculator and with right triangle trigonometry. Until next time, keep your pencils sharp, and I'll see you in class.